All right, as we start up then on Chapter 11, if you look up on the screen, this is what I sent you this morning, and it has 4 things in it. It's got the you do it first example, the you do it second example, the you do it third example, and the test review for Chapter 11. So if you can open those up, extract the zip file and put it wherever you put your stuff, then we'll start up. So Chapter 11, if you're following along in the book, it looks like we're on about page 489. It's on exception handling. And as mentioned the other day, when you talk about exceptions, they're exceptions to the norm. They're not a good thing. All right? There's 2 ways that you can handle, or actually there's 3 ways that you can handle error conditions in a program. One is what I call the Ostrich Method, where you just hide your head and you hope that the person running the program never makes errors. That's probably the most foolish way of doing things, all right? But fortunately or unfortunately, there is code out there that is written like that, all right? That's the first way. The second way is the way we've been handling it so far. In other words, when you've had problems, if we wanted to check to see if something was within range, for example, we used if statements, all right? And that's a very common way of doing error handling. The other way, the object-oriented way of doing error handling, is by using exceptions. And what you're going to see as we go through the chapter is you'll say the word try, and then you'll put in 1 or more lines of code that could potentially fail. And then you'll use the word catch, and that means that if that really does fail, this is the code you want to have happen. And you can, but this is optional, you can put the word finally in there, and that'll do any kind of housekeeping type of thing that you want to do. Close a database connection, close a file, or whatever. So in a nutshell, that's what we're talking about today. All right? So we will talk about the main classes, the exception class, etc. All right? We will talk about the ability to be able to catch multiple strings. I should say catch multiple exceptions. All right? We will look in a little more depth and breadth of coverage at Tryparse. I gave you Tryparse much earlier in the book, so this shouldn't be a big surprise to you. We've been using Tryparse to make sure that something that's supposed to be numeric indeed is numeric. We've been using that for a while. The finally block I've already talked to you about, and we'll end in here by talking about how to create our own exceptions. Now, what I'm planning on doing today between now and no later, hopefully, than 10 o'clock or so, is to go over this chapter, go over the review at the end of the chapter, and do that test review document. And the rest of the period will be lab. Then tomorrow we will go over 4 examples, something like that. All right? And I've actually got 4 problems I'd like you to work on at the end of this chapter. Talk about those later. We'll do at least 2 of them in total as a class tomorrow. All right? So again, as mentioned, an exception is an exception to the norm. It's not a good thing. All right? How can you get an exception? Well, you ask the user their age and they type in none of your business. All right? So in other words, it's looking for an integer and you give it a string. That's an error condition. All right? It asks you for a string value. It says, what's your name? And you put in there a number. Can result in an error. All right? You're asked to enter 2 numbers. You enter 6 and you enter 0. You're making a simple calculator. And one of the operations is divide. You choose that option. You attempt to divide by 0. That's an exception. There are other things. All right? Attempting to access an array element that's out of range. Those are the main ones. The way that you handle exceptions, this shouldn't be a surprise to you. You handle exceptions by using what are called exception handlers. All right? Some of the different kinds of exceptions that you can come across are shown on page 491. In fact, the table takes up the entire page. You can see how big that is. Now, how many of these are you going to see? Quite a few of them if you become a C# programmer. For us, what we concentrate on more than anything else in this chapter are things like argument exception, arithmetic exception, format exception. Some of these we don't get till the end of the book. If you look here up on the screen, right up near the top, it says system.io. And I/O is an acronym for input-output. And that's typically if you're working with files. We don't even touch on files until chapter 14 of this 14-chapter book. So we won't worry about anything like that right now. Some exceptions you can't handle, if you look on the screen here. Out-of-memory exception. If you're using a really old computer, or if you're using a computer that has very little memory left in it, and the system throws an out-of-memory exception, there's probably not a lot you can do about it except remove other programs that you've got running, remove other software that you have on the machine, etc. If you go, well, I can't do that, then you just might not be able to run the program on that machine. All right? Now, guaranteed, this question is on your next test. On the top of page 492. It's also on one of the questions at the end of this chapter in the review. Most exceptions that you use derive from one of three classes. The first is system exception. The second is application exception. And the third is just exception. What does that mean? That means that all those different types of exceptions that I showed you on the previous page are members of one of these three classes. All right? Notice you've got predefined what are called CLR, or Common Language Runtime exceptions. All right? That's the system exceptions. You've got the user-defined exception classes. These are the ones you create. All right? And then you've got the thing that's the parent of both. The real cheap, down and dirty, cheesy way to handle exceptions is to use this last way. You're going to see that in just a couple minutes. All right? So the first thing they have you do in here is they have you purposely come in and start making mistakes. Everybody hear that? The best way to learn exception handling is to have exceptions come up in your program. All right? So the first thing that the author has you do in here, if you take a look up on the screen, this is a simple miles per gallon program. All right? You'll notice that we have three variables: miles driven, gallons of gas, and MPG. Now, I personally would have made MPG a double. They didn't. It's no big thing. But the point is, you can tell when you do the calculation, miles driven divided by gallons of gas. So when you ask the user to enter in the gallons of gas they purchased, if you put a 0 there, you will be attempting to divide miles driven by 0. What that's going to do by default is it's going to throw an exception. And in fact, if you look on the screen, maybe you've seen this before. I don't know. Because you can get these exceptions in either GUI applications or in console applications. You're going to see examples of both. All right? But as it says in here, notice what happened. It says enter miles driven, 300. Enter gallons of gas used. You got 25 miles per gallon. That makes sense. You had two valid inputs, you get a valid output. Next, enter miles driven, 300. Enter gallons of gas purchased, 0. So you get this system.divide by 0 exception. Attempted to divide by 0. It's doing the best it can to tell you what the problem was. It's not pointing you out right to that line in particular, but it's letting you know that you attempted to divide by 0. So you'd go back to the program, you'd say, where am I dividing? Well, I'm dividing right here. So the error has to be on that line. And we're not accounting for that error. All right? And that's exactly what the author is saying right here. All right? And it says just because an exception occurs and an exception object is created doesn't mean you necessarily have to deal with it. So you don't have to deal with exceptions. The problem is if you don't deal with an exception who or what deals with it? If you don't do it, how is it handled? Come on. It's what? No. The computer. The software handles it. And the way the software will handle it is the program will terminate. All right? Not typically what you want to have happen. That's exactly what happened on the previous page when we looked at this. The program terminates. You put in something illegal, an exception was thrown, you didn't handle the exception, so the program terminates. Sometimes that might be what you want to have happen. You know, if you're asking for information and if the user can't supply it, you might want the program to just terminate. Sometimes you don't want that to happen. All right. Sometimes you want it set up so if the user puts in bad data, you want the program to continue. Maybe you change it to a default amount, or maybe you do something else. If you look on here, they give you an example of the term mission critical. And it says it refers to a process that's crucial to an organization. All right. Here's an example. Let's assume that you work at a company and you wrote the payroll program. All right. And you know, for some reason, somebody, you always have files that contain the payroll data. Make sense? All right. It's got names, the number of hours they worked, their amount per hour, and let's say every other Friday, that program runs. Okay. Now, somehow, someone who did some of the clerical work fat-fingered, and when they put in the number of hours you work, instead of putting in 40, they put in 40, but when they did, afterwards, they hit the minus sign that's right next to it. So it says 40 minus. Technically, that's invalid, right? All right. You can set it up so that if there's a bad value put in there like that, the program continues on. If it's the first record, and I'm expecting that money in my bank account by Monday, let's say, and it's not there because there was an error in the payroll file, that doesn't help people. You know, if I start writing checks against that and there's no check in there, I'm going to be in trouble. All right. The bank doesn't care that the software for the program screwed up. All right. So when something's mission critical, what you're saying is it's something that has to keep running. All right. And again, you think about it. You're mission critical. You know, I remember taking a class. I went out many, many years ago. I went out with this woman who was into transcendental meditation. So she dragged me with her to this seminar. And the guy started the seminar by saying, there is nothing in the world that you have to do if you're willing to pay the consequences. Somebody raised their hand and said, you have to breathe. And he said, not if you're willing to die. And when you think about it, it's true. But if you define for the company that you work for that there are certain things that have to keep running 24/7, those things are mission critical. So in order to keep it mission critical, you try to build yourself what's called a fault tolerant system. With a fault tolerant system, as it says, it's designed to continue to operate, maybe at a reduced level, but it keeps operating regardless. Then there's another word in here, robustness. And as it says, it's the degree to which the system is resilient to stress. So if you put bad data in, how well can the program handle it? All right. So let's look at this first. You do it. You've got this. You don't have to bring yours up, but I'm going to bring mine up. And after I do, let's take a look at what it says in here. First of all, I'm going to bring up, this is the first one. There's 3 of them in the chapter, and they just keep building on each other. So if we look in here, this is the whole thing. The program comes in and it says enter an integer. All right? And then it attempts to convert it. So there's 2 places this program could blow up. It'll say here, enter an integer. If I put hello, the program's going to blow up. Would you agree with that? Because it's going to attempt to do a convert to 32, and it'll blow up. It'll give me an exception. So let's say I do put a valid value in there. I'll put in 10. Then it's going to take 10 and divide it by 0. So it'll blow up there. So let's look at both those cases. In fact, let's look at 3 different cases. First, it says enter an integer, and I want to put in 10. But I don't type the number 10, I type in the letters TEN. I hit enter. And you notice the program blew up. This is called the exception assistant right here, this thing. It's called the exception assistant. It's designed to give you information about the program. So it's telling you, you had a format exception. It's telling you right where you had the format exception. It's letting you know as best it can what you did wrong. So when you do this, you can even view the detail, etc. Input string was not in the correct format. All right? It's doing the best it can to tell you, hey, somehow you screwed up. All right? So this is one of those exceptions, system.format exception. All right? What if I come back in there and I run it again and I put in 10, but instead of putting in 10, I put in 10.4. This was supposed to be an int. So I hit enter. Again, I get another format exception because it is trying to do a convert to int 32. The minute that it finds that decimal point, it blows up. It doesn't know how to handle it. All right? So let's run it one last time, and let's actually give it a valid value. So now we come in here and we put in 10, and we hit enter. And you notice now we get a different exception. Previously, for the other two, we got a system.format exception. Now we get a system.divide by 0 exception. And it's telling us, you attempted to divide by 0. Division by 0 results in infinity that the computer can't handle. Different languages handle this differently. Now, other than you and Josh, all the rest of you, if you remember, you were in the class last semester, and if you did a 10 divided by 0 in JavaScript, it would come back, and I think it literally said infinity. It would say that. So it could handle it. C# is not one of those languages that can actually handle that. It doesn't know how. So again, all 3 of these examples showed you if you don't handle the exception will be handled for you. Does that make sense? All right. And typically, the way it's going to handle it for you is it's going to shut the program down and give you an error message. All right. And that's exactly what they're talking about right here. So let's kill this and let's take a look at what's in the book here. Start a new project, put all that stuff in. I did it. You cannot divide by an unnamed constant 0, which is this. All right. Or just the number 0. Okay. It says using the variable 0 instead of either one of these, the compiler trusts that you know what you're doing. So the system is figuring that you have a clue. Now you might have a clue, but if you're writing a program and you want other people to give you input, they might not have a clue. All right? So they tell you to execute the program several times. That's what I just did. And they mentioned that when it comes up, this is a little older, but it says, what do you want to do? Typically, when you get an error like that, as you saw when we got these errors, so I'm just going to run this. Let's put in, when you get this and you get that error, why it's not, okay. There. When you get this, typically the way that you resolve it is you click this X, and then you click the red square right there, which says basically, hey, I'm closing that down. That's almost always what you're going to want to do. If that comes up and you get an error message and you're not at all sure what it is, you look at the exception assistant and you try to read the information, all right, to get some info on why the program indeed closed down. All right, so they show examples of each. All right, pretty much what I just showed you. Now again, if you don't put in code to handle errors, the system will typically go to the limit and just say, well, I don't know what the heck you want. I'm closing it down. All right? So an advantage, as it says, to using exception handling, all right, is you'll have it, you've got control. What we've done so far is we've always used if statements. And the author says right here, this is on page 498 in your book, right near the top of the page, where the author says here, an advantage of using exception handling rather than decision making, rather than ifs like we've done, all right, is that the program's main logic is interrupted by a series of if statements and decisions that might detect errors. Now, some people would say, so what? The program will run a little slower, but it's easier to write. All right? Just to show you, this is off subject, but if you look here, I'm writing some Android code right now. All right? And if you look, rather than using try catches, which I could do, I'm using if statements. That says if you put in a loan amount that was less than a minimum or greater than a maximum. All right? That's how I'm going to handle it. I could also put try catch statements in there, like you'll see later. All right? Now, this is the key to the chapter on the bottom of page 498 and the top of page 499. As I already mentioned to you, when you're working with this stuff, you end up using what are called try catch statements. So you go, and where I've got up on the board there, try, and I just put 4 lines. That's, you put in there any code that could conceivably fail. All right, so you put in your code that could fail. Then in the catch, you put in how you want to handle it if that code does fail. And you can, if you want to, need to, put in the word finally. Typically, you put in finally because finally runs whether the try succeeds or the try fails. Please look up on the board, all right? Because I'm just going to try to show you this without any code. So imagine here we've got 4 lines of code. All right, I just labeled them 1, 2, 3, and 4. If line 1 completes successfully, then line 2 completes successfully, then line 3 completes successfully, then line 4 completes successfully, you totally skip the catch and you go down to there. Does that make sense? All right. But imagine that didn't happen. You do line 1 and it completes successfully. You do line 2 and it completes successfully. You do line 3 and there's an error. Whatever it is, there's some kind of an error. Then what happens is, if there is an error right here, what happens is the system says, okay, there's an error in my try. It looks for a catch that would be associated with that try. If it finds that catch, it does all of that code. Then it does the finally. All right? Once you go into the catch, there's no go-to. You can't say, well, I fixed it. Go back up there and do number 4 now. That doesn't happen. You cannot do that in this language. All right? There's other ways that you can handle that. But what I want you to understand is, inside of the try, you put 1 or more statements that may potentially fail. Inside of the catch, and you can have as many catches as you want to or need to have. But inside of the catch, you put 1 or more lines of code you want to have run if the code in your try fails. And the finally here, which is optional, always runs. So if this all works, you jump down to here. If that fails right there, you do this, then you jump down to here. All right? You don't need to put in a finally. A lot of developers very rarely use a finally. All right? So that's what's explained on the bottom of 498 rather, and the top of 499. Okay? The only way that you're going to understand this is to see it in action. Everybody hear that? The only way this will make any sense to you is to see it in action. All right? So like I said, tomorrow we're going to go over a couple of the exercises at the end of the chapter. Okay? So this is basically the format for the try-catch. Everything that's in there is what I just mentioned to you. So here's an example. Now take a look at what's on the screen. Please, you got to understand this. This, I guarantee you, will be on your test. You will have to write probably multiple try-catch statements on your next test. All right, at least 2 that I can think of right now. Maybe 3. So, try. So notice what happens. It says enter miles driven. So let's say you put in 300. Boom, it's all cool. Enter gallons of gas purchased. You put in 0. Now it comes in here and it attempts to take 300 and divide it by 0. It fails, but it's going to throw an exception. This says handle any exception you find. This is the most generic exception handler there is. So what is it going to do? It sets miles per gallon to 0. It says you attempt to divide by 0, and you got, whatever miles per gallon. And it'll say 0 miles per gallon. The point is, though, the program doesn't break. It's like, some people will say that it bends, but it doesn't break. All right, so if you see that up on the screen right here, the first one still works just fine. But when you do the second one and you put a 0 in, now you get an error message. But the program does not end. All right, it doesn't abort, terminate, whatever you want to call it. So again, that is shown in your book on page 500 and explained on page 500 and page 501. All right. Now, what happens when you get this stuff? If you look up on the screen here, please. Did this before, so I'm going to come in here, run it again, and put in 9. Okay? See this right here where it says attempted to divide by 0? Everybody see that? That's actually what's referred to as a system message. You can print out those system messages or you can print out your own stuff. When you do a catch statement, it's a write line, and you know already from write lines that you've done, you can write anything you want in a write line. All right? So you can not only write whatever you want, but you can add to it a system message. Sometimes it makes a lot of sense to put the message in there and let the user know exactly what they did wrong, how they screwed up, however you want to put it. So again, we've got a try right here, and now we've got a catch. Notice what they wrote, e.toString. See that? That's everything that's here. System.divide by 0 exception, attempted to divide by 0. See that line right there? That's the same information that we just saw in here. Why it's every other time now it's just flaking out. All right. So that's this system divide by 0. That's where it's getting that. And attempted to divide by 0, it's getting right there. So it's grabbing that information from the actual assistant itself, and it's putting it in the book. That's what the author is trying to tell you right there. All right, E, where it says exception E, there's nothing special about the word E. Here's a real hard question for you. Why do you think they use the word E? Because that's what exception started with. Sometimes I see it in there as EX, all right? Sometimes you see it as something else, but typically it's E. So the E.toString says, hey, I want to print that system message. So they're printing a system message instead of your own. You can print both if you want to. You can have your own customized message, and you can have the system message. You can even have your own customized message and put the system message in there. All right, so there's a heck of a lot of ways that you can do this. All right. Again, they just show you a bunch of examples. All right, so let's look at the second you do it here. This is on the bottom of page 505, and it goes on to page 506. All right, I tried to come in here and even show you, so I'm going to close this solution and open up the next one. So what have they changed in here? Well, They've added this try catch. And what have they removed? They removed this stuff where they weren't doing any checking. So now they're doing checking. So let's look at what's going to happen here. It says enter an integer. All right, then it's going to attempt to convert it right here. I'm going to first run it. I'm going to put hello in there. That's going to fail. Then it's going to jump down to here, and it's going to write down the message that the system came up with. All right, then I'll run it again, and I'll put in here 7.7, and it's going to fail with another format exception. Then we'll run it again, and we'll put in a 3. All right, now we have to go back and change this. This was originally just said, if you remember, it said the answer, right, just said int answer. It didn't say int answer equals 0. We had to change it because if we don't, we get an error message that it wasn't initialized. So let me run this one. You saw how it broke before. All right, what's going on here? No, I don't know what's going on here, but it didn't load my project right. All right, so now when I run this, exact same inputs we had last time, but now I'm going to put in hello. And you see, the program didn't blow up, so to speak. It gave us, this was the system message. Input string was not in a correct format. But then we just changed the answer to 0. The point is, now we're making this fault tolerant so that the program could still continue to run if this was in a loop. 7.7, same thing. Input was not in the correct format. Run it one last time and put in 6. Now notice, attempted to divide by 0. Those are all the system messages that we're printing out. All right, so we have taken control over the program, for lack of better words. And that's exactly what they explain in the book here on pages 505 and 506. All right. All right. Now, if you noticed, maybe you did, maybe you didn't, please look up on the screen here. So far, this is all we've done. Catch exception E. But if you remember, I'm not going to turn back to it, but at the beginning of the chapter on page 491, they showed you on page 491 about 10 or 15 different kinds of exceptions. All right? This isn't giving a lot of information. This is what's called a generic exception handler. Now I'm going to do something that's not in the book here. All right? I'm going to come in here and I'm going to come in here and do this. I'm going to say catch, and I'm going to put in here format exception. FE for format exception. All right? And I'm going to do another write line in here. All right? And then I'm going to come in and put in another one. Catch, and I'm going to put in a divide by 0 exception. And I'll put it in here, I'll say, instead of FE message, I'm going to put my own message. You inputted a non-numeric value. Something like that. Not great, but that's fine. Write line. You illegally attempted to divide by 0. You see what I've added? I've added 2 exceptions. So I've added one in here that's called FE. It says it's declared but never used. Okay, that's true. Okay, and I'll tell you what, we'll say this. Plus FE dot message. All right, so we will print out their message. We'll print out our message and then their message. All right, this will be a divide by 0 exception. DE So we'll call this \n plus de dot message. Everybody understand? If you look on the screen, please. This is the same stuff you're going to do on your test. So what we're saying is, I'm going to run this, and I'm going to put in hello. That's going to throw a format exception. So when I put in hello, it should say you inputted a non-numeric value, and then it'll give me the system message. Then I'm going to run it again, and I'm going to put in 6. It's going to divide 6 by 0, which will throw a divide by 0 exception. So it'll say you illegally attempted to divide by 0, and it'll give me the message. Does that make sense to everybody? All right. So I'm going to save this and run it again. So again, hello. You input a non-numeric value. That's what I put in. That's my message. This input string was not in a correct format. That's the system's message. All right. Then I'm going to run it again. And I'll put in a valid number, 43. You illegally attempted to divide by 0. That's my message. Attempted to divide by 0. That's the system's message. All right? So, that's an example of multiple exceptions. Here's the one they show in the book. All right? This is on the bottom of page 507. You can throw as many exceptions as you want to or need to do. Now, please look up on the screen here. I don't know. I haven't tried this, and I should have. But I'm hoping that when I attempt to change this, I get an error. I'm trying to get an error. All right? I'm going to grab this exception right here. I'm going to cut it, and I'm going to move it to the top. All right? It's giving me an error. Please look on the screen, everybody. Would anybody like to take a wild guess as to why it's giving me that error? There's nothing syntactically wrong with the line catch exception E, write line E message. There's nothing wrong with it. The problem is you've got to put more specific ones before you put the more generic ones. Do you understand what I'm saying? You have to take any exception that you write. These are specific exceptions. These must come before this one. The reason is, if you put that one first, you can't possibly ever catch these. So you've got to put the most specific exceptions first and the least specific exceptions after that. All right. In fact, if I put my mouse over this, notice what it says. The exception that is thrown does not meet the parameter specifications. A previous catch already caught it. And it's going to say the same exact thing right there. It's letting you know I can't even call this exception because you put this more generic one. Notice if I get rid of the generic one now, everything's hunky-dory. There's nothing wrong. I can still put it there, and most developers put that one there as a safeguard at the bottom. All right? So that's what's explained in the book on pages 507, 508, 509, and 510. All right? Let's go through one more of these. Maybe you are ready for a break. So let's look at the example that's starting on page 511 in the book. There's one last you do it exercise in here. All right? And that's number 3. And they have several different kinds. It's pretty much what I just showed you. All right, so I'm going to take this, and I'm going to close it. Yeah, I can save it. It doesn't matter. And here's number 3. Again, this will look very similar to what I just showed you. But notice, we've got a format exception, and we got a divide by 0 exception. You'll notice that these both have green lines underneath them because it's saying, hey, you've got this thing called E that you're never using. Bless you. But I can do this if I want, and I can say, my message plus system message. And I can say now e.message. All right. So notice when I run this and I get a format exception, now I've specified my message and I've specified the system's message. All right. I don't know, if this author, if she's like a soft touch person, I love this. This is not your fault. You entered the integer correctly. The program divides by 0. All right. So she's trying to let you know it wasn't anything you did. It's just something that was put in the program, I believe at least, for demonstration purposes. Make sense? All right. Let's take a break right here. We're at 40 minutes on the tape, which is fine.